This is a longer introduction to the WISE image service at IRSA. From the IRSA homepage, find WISE, and then click on WISE image service. By default, you're dumped into a position search. You can put in a name and have Ned or Sinbad resolve the name. Or you can put in coordinates in any of a variety of units. You can put in M16. It resolves the coordinates below the box to make sure that it understands you correctly. The next choice is search type. You probably want image contains target, but there are other choices. The image size defaults to 600 arcseconds. If you choose to leave this blank, it will return the entire WISE tile. Now, the next choice can be a little bit confusing. Return only the most centered image containing the target. If you just want the best possible WISE image for your target, you might want to set that to yes. The difficulty is that if you just want to see all of the available data, you probably want to set this to no so that you get all of the possible images of the image sets that you pick. I usually leave that as no. The next choice is image set. There's another video that talks about what all of these image sets are. I'm going to tick all of them. The data product level, Atlas, is the summed up mosaics, and single exposure are the individual frames. I'm also going to ask for all 4 of the WISE bands. Search. These are the results. There's a list of results on the left, and the stuff on the right changes depending on what you've picked on the left. You can control the relative sizes of these window panes, and there are tools in the upper right of the tables and the images that affect the contents. There are other movies and online help that go through these in more detail. You'll see me use some of the more important features as we explore these results. Now, it seems to have sorted these results in somewhat of a peculiar manner. It sorted these by COAD ID, which is not the same thing as sorting them by observation date. But COAD ID makes the most sense because it's grouping the images by image sets. Image sets are an important concept within the WISE universe. If I click on this, you can see that it's showing me 4 images on the right because there are 4 WISE bands. These 4 highlighted rows correspond to the 4 images on the right. The darker yellow corresponds to this highlighted image. If I select a different image from this 4-row image set, that's the one that's highlighted here. If I select images from a different image set, then they all reload. Here's where it gets a little bit confusing. These 3 images come from the 3-band cryo data delivery. It's expecting 4 images because 4 images make up an image set, and that's the way that it's saved. And it saved space for 4 images. But there are only 3 images in this image set, so it throws an error. It's not terribly user-friendly, but there should only be 3 images here because there are only 3 images in the image set. Let's go back to a 4-band image set. These 3 icons here control whether you look at one image at a time, all of the images that you returned, or all of the images from the image set. If you look at all the images that are returned, the dashed lines show you the other images that are in that image set. The image set view shows all of the images from the image set. This button here creates a 3-color image. By default, it picks band 4 for red, band 2 for green, and band 1 for blue. You can change which band it uses by selecting that. If I click show 3-color, then it adds another image with the 3-color image shown. If I click on it again, I can either hide the 3-color image or change which band is used. Note that in the case of NeoWise data, where there's only 2 bands available, you can reuse one of the bands or you can disable one of the colors so that you can use just the 2 NeoWise bands. Let me also highlight that these are fits images, so you have some control over here. You can change the color table, you can change the color stretch. Even in the 3-color image, you can change the color stretch and you can change the properties of the individual color bands in that 3-color image. You can also lock the images together by WCS so that when you zoom in one, they all zoom. Now for this search, we asked not just for the atlas or mosaic images, but for the individual exposures. you can see the individual exposures here. You can see, if you zoom in, that there are individual cosmic rays affecting these exposures. Let's go back to zooming out and then unlock the images. For this example, it's probably pretty useful to go to the coverage map. Here we have a HIPS image in the background. The HIPS images are different than FITS images and are designed to cover large areas of sky. You can see that the large polygon there is the atlas images. Because they're all the same tile, they all show up pretty much on the same polygon. If I go to the single exposure tab, all of those pink polygons, you can see the swatch there, all those pink polygons are the individual exposures that are returned. Let's go back to the data tab. We have the same kinds of visual cues and display that we did in the Atlas tab. These 4 images are part of the same image set. This is the currently selected one, and the dashed lines indicate the other images from that image set. Go far enough down the list, though, and you eventually find some NeoWise data, where there are only 2 images in the image set and 2 images that are linked here. To download data, tick boxes from a row or select all of them, and then once you've selected the rows that you want, click on Prepare Download. You can download all 4 bands and a variety of ancillary files. When it talks about structured or flattened file structure, this is what it means. Do you want individual data files in subdirectories corresponding to image sets, or do you want it without subdirectories? This is asking for the file name that you want and whether you want it saved to your local disk or the IRSA workspace. After you click Prepare Download, it spins it off to the background monitor. If you're zipping and downloading a lot of data, it might be worth putting in an email address so that it can notify you when it's ready. But on the other extreme, as you just saw, sometimes if you're downloading a little bit of data, it may happen so fast, sometimes you might not even know that it's done it. Your browser is configured to save files in a particular location, so you may need to check your downloads file to find the download. That's the basics, but this is a longer video, so let's go through some of the additional features. The other default tab is Search by Solar System, Object, or Orbit. This is a special kind of search, sometimes called pre-covery. What it's doing is finding the orbital parameters for an object and then calculating, given the orbital parameters, where this object is over that time, and then looking to see if there are any WISE observations that happened to overlap the calculated position of the object. Here you can put in a name like Karen, and then you have to give it a second to go talk to the database and then pick the NAIF ID. You have to give it a chance. Talk to the database and then pick the NAIF ID that corresponds to that target, because under the hood, everything is tied to that NAIF ID. If you just put in the name, even if it's a famous name, even if there's only one choice from that pull-down menu, that's not enough. You have to select that NAIF ID. Then you need to tell it a range of dates. If you put in a long range of dates, this calculation can take a long time and, importantly, not be accurate. If you extend over a very long time baseline, you can understand how these calculations might be increasingly inaccurate with time. Once you start having non-Newtonian forces, for example, with comets, that orbit calculation gets increasingly inaccurate. If you need to play with the orbital parameters, you can put an MPC one-line input for an asteroid or a comet, or you can put in the individual orbital parameters. So we'll go back to the Karen search, and we'll go ahead and ask it to search for individual exposures over all of those image sets. Search. Okay, so here are the individual exposures that it found, but let's start by looking at the orbital path on the coverage map. That's the orbit that it calculated. You can see, if I zoom in, you can see the loops and wiggles as it's moving retrograde. If I zoom in close enough, you can see the individual epochs that it's calculated for that orbital path, and the individual frames that it found are highlighted here. If I click on the image, then they're highlighted in the table, and it works the other way too. If I click in the table, then they're highlighted in the image, but it may not jump to that location in the image. If you go to the Data tab, you can see the individual frames, and the reticle there is showing you the calculated position of Karen as a function of time in these individual frames. When you do this search, you can choose to search the catalog at the same time. The reason this is particularly useful is because each of these image sets have different individual exposure catalogs that go with them. So it sometimes can be painful to do the manual searching of each frame by frame, because of course the object is moving. When you do toggle this to yes, you can ask it to search a particular radius, and then it will overlay the catalog on each corresponding exposure. For inertial targets, though, there's no way to search the catalog at the same time. So catalog searching is a separate step. Let's go through all of the additional tabs that you have. If you go to this icon here, this icon is sometimes called a hamburger. Let's click on that. This is where you can add or hide additional tabs. Catalog upload. This allows you to upload a catalog of any of a variety of formats into the tool. You can also search in a variety of other ways. For the regular position search, you can upload a multi-object search, but you can also search by scan ID or frame number. You can also search by COAD ID, including an upload of a list of COAD IDs. You can also search by WISE source ID. This is not the IAU compliant position-based name. This is the level 1B or level 3 source ID search that looks like this. You can also figure out what image a source was extracted from based on the source ID. Now, here, this is where you start to actually search external catalogs. The Catalogs tab here gives you access to catalogs held here at IRSA. The WISE catalog is the default search, but you can pick any of a variety of projects here at IRSA. Then you need to select the specific catalog. All WISE, probably what you want for inertial targets. Before I search for this catalog, let's go back to search by position and single object and make sure that we have M16 source results in here. And then let's go back to the Catalogs tab. So let's do a cone search, not for 10 arc seconds, but for 1,000 arc seconds. Search. So it's found a 5,000 row catalog, and it's made a plot here. If we go over to the Data tab, you can see that it's overlaid the catalog on the images, but it's done so in a hierarchical catalog display. If I zoom in far enough, it does show me individual sources, but zooming out, it's showing me in these cells. I have some control over these cells. Each of these cells, like that one has 20 sources, that one has 23 sources. If I click on the cells, then it shows me the contents of the cell. But I can change the color that it uses, how it's showing those cells, what the minimum group size is for those cells, and exactly how big those cells are. So I have some control over that. But again, if you zoom in far enough, it will show me the individual sources. It also makes a chart. By default, it makes an RA and DEC chart because it knows that RA and DEC are going to be part of that catalog. Let's go to the gears and change what's plotted. For the x-axis, we can do W1 MPro minus W4 MPro, which is WISE1 minus WISE4. And then for the y-axis, W1 MPro. Since this is a color magnitude diagram, let's reverse the y-axis, apply, and close. So now we've got a color magnitude diagram. Now, because there are so many sources, it's created a grayscale plot where each one of the points represents more than one row in the catalog. But let's go here and let's filter down what's in the catalog. Let's filter this down so it's just the higher signal to noise sources in WISE1 and WISE2. You can see already we've got fewer sources in the catalog, few enough that individual sources are shown in the plot. If you click on the source in the plot, it'll show you which source that is in the table. And if you go to the data, it should highlight it in the image as well. But since the sources extend beyond the edge of the image, it's not actually showing it to us. Let's see where that source is in the plot. It's there. So they're all interlinked like this. You can save the plot by clicking on the diskette here. You can save the table by clicking on the diskette here in any of a variety of formats. The other tabs that are over here, you can do a VO tap search. VO is Virtual Observatory, TAP is Table Access Protocol. That tab that's labeled VO tap does an IRSA search. So it's the same catalogs you get from the Catalogs tab, but in a slightly more sophisticated interface. And if you design it using this interface and you're learning ADQL, once you design it this way, you can populate and edit ADQL. So now you've got the ADQL that you can copy into your Python code. If you go over here, you can do a NED search. You can also do a multi-archive VO tap search. This is the same kind of search as the VO tap search over here, except now you're not limited to just IRSA services. You can search tap services from all over the planet. Note too that there's online help You can also click on the context-sensitive help anytime you see a question mark in a circle. If you click on that, it'll drop you into the documentation specific to whatever it is that you're looking at.